Today I'll be talking about the n-spire calculator. So when you open up your n-spire, you'll see the home screen, and it has the calculate function right here, and then the graph function right beneath it. And then on the bottom there's a row of functions that you can use to create savable documents. So if you click on the calculate function, it opens up to a scratchpad which looks similar to something you'd see in a TI-84 or something like that. And down here you'll see a button which contains a lot of functions that are useful in calculus. So if we click on that, it opens up into this, which has many features such as like absolute value, just fractions in general, square roots, and we'll be looking at the indefinite integral function. So if you click on that, it opens up into an indefinite integral symbol. And you can do something like x to the 4 plus x cubed plus 6x squared plus 5, and then you have to put it as dx because that's what the function is in terms of. If you press enter, it gives you this, which is the antiderivative or the indefinite integral function, which is x to the 5 over 5 plus x to the 4 over 4 plus 2 times x cubed plus 5 times x. And if you're doing this on a test, don't forget to add c. So this works with a variety of functions. So you could do something like an equation in terms of y, such as the fifth root of y, and then it would be dy because it's in terms of y. If we press enter, that gives 5 times y to the 6 over 5 over 6, of course plus c. In addition to being able to find indefinite integrals, the n-spire could also find definite integrals, which is super useful for saving time during tests on the calculator section. So if we look at the function button and select the definite integral, which is this one, it gives us this notation, which is the area under the curve of a function within a certain interval. So if we want the area under the curve from 2 to 5 of the function square root of x raised to the 5 minus 6x raised to the 3 dx, it would look like this. And if we press enter, it gives us this answer, which is 250 root 5 over 7 minus 60 root 2 over 7 minus 1827 over 2. And if we want to see this answer in decimal form, we can just select the answer right here, highlight it, press enter, which gives us right here. And then if we highlight it again here, and go to the menu, and click on number, and then convert to decimal, and press enter, it gives us this answer, which is negative 836.873, or approximately negative 837. So another great way to find the definite integral function is to go to the graph function. And if we click on the graph function and then click tab in order to input our function, then let's put the function in, which is square root of x raised to the 5th power minus 6x raised to the 3rd power, and graph it. It gives us this graph. And then to find the area under the curve from from positive 2 to 5, we go to menu, and then analyze graph, and then integral. Oops, menu, analyze graph, and then integral right here. And it's asking for the lower bound function, so we'll put 2 and then press enter. And then it asks for the upper bound function, so we'll put 5 and press enter. So this gives us negative 837, which is just the answer the scratchpad calculator gave us, rounded to the routed to the nearest one. So that's another great way to find the definite integral of a function, and both ways are great ways. It's just once in the calculator, one's more visual. Farrar can also be used to find the area between curves. So if we graph the function 2x raised to the second power plus 4x raised to the third power, and then we want to find the area between this curve, and by pressing tab we can enter a second function, find the graph 4x, and if we want to find the area between these two curves, then what we do is by pressing menu and then analyze graph and intersection, we can find the intersection points between the two curves, which there are 3. So upper bound and lower bound, and it gives us this intersection, negative 1.28 and negative 5.12. And then we'll do that for the other 4, so analyze graph, intersection, lower bound, upper bound, and it gives us 0, 0. And then finally we go to menu, analyze graph, intersection, and then lower bound, upper bound, and it gives us 0.781 and 3.12. And so now that we have the intersection points of the two functions, then we can go to menu, analyze graph, and then bounded area. And we can select the point of intersection as the lower bound point, and then the point of intersection as the upper bound point. And this gives us 1.99 as the area between the two curves in that region. And if we want to find the area between the two curves over here, then we just go to menu, analyze graph, bounded area, and then we select as the lower bound the point of intersection in the middle, and as the upper bound the point of intersection at the far right. And it's hard to see, but the value here, it gives us 0.53 for the area between curves in this region. And that's a great way to find area between curves on the n-spire. n-spire can also do slope fields. So if we click on menu, and then we go to graph entry edit and select differential equations, because that's what we work with when making slope fields, then it shows up like this. So the input y1 prime is equal to something, and we'll be working with the differential equation y1 prime is equal to 2x, and this would make y1 equal to x squared plus c. So if we click enter, it gives us this slope field. And if we want to make the resolution higher for this slope field, then by pressing tab and then going back to y1 using the up arrow, then we can click on the edit parameters button and scroll down, and we can change the field resolution to something like 30. So now you can see that at x equals 1, the slope of the slope field is equal to 2, because 2x evaluated at 1 is 2. And if we want to show the slope field passing through a point, then by pressing tab and using the up arrow to go back to y1, and then we can set the x0, y10 at 0, 0, and then enter. And so this shows us the slope field that passes through the point 0, 0, which is just y equals x squared. So this is a simple example of how you can use the n-spire to make slope fields and change the parameters and have them pass through a point. So by now you should be able to take definite integrals, indefinite integrals, find the area between curves and where curves intersect, and make slope fields on your n-spire. I hope you found this useful in your AP Calculus classes. Thanks for watching.